Hi guys, in this video I want to talk about some examples where we find equations of lines with given characteristics. So let's just jump right in. Example 1 asks us to find an equation for a line that's parallel to this line 18y equals 17x minus 24 with a y-intercept of 0, 1. So the first thing to note is that the y-intercept of this line may not be the y-intercept of the line that we're looking for, but the information that this line does contain is the slope. So let's just get this into slope-intercept form. Let's find out what the slope is of this line. And to do that, the only real barrier that's in front of us here is that we have this 18y, right? So we need to make that y instead of 18y, so we divide both sides by 18. So we divide both sides of this equation by 18, which leaves us with y equals 17 over 18x minus 24 over 18. So this now is in slope-intercept form. It's in this form right here. Now what we need to do is we need a line that's parallel to this one. So we need a line parallel to this line with a y-intercept of, or a b value of 1, right? So we know the answer should look something like y equals mx plus b. So I'll just fill in the x. And then we also know that the b here is 1 because the y-intercept is 1. And now the last thing that we need to recall is that parallel lines have the same slope. So a line that's parallel to this line will have the same slope as this line. So this line has a slope of 17 over 18. So therefore, this line that's parallel to it with a different y-intercept is given by this equation. Y equals 17 over 18x plus 1. Next, what I want to do is I want to tackle another example. So for another example, let's look at the case where we want to find not a line that's, or find not an equation of a line that's parallel to another line with some given point, but instead let's look at a different case where instead we look at, we try to find an equation for a line that's perpendicular to a given line going through a given point. So that's a lot. Verbal mouthful, right? But let's look at an example. So let's say we want to find an equation of a line that's perpendicular to, so this is actually example 4 in the text, so I'll write that just to be consistent with the text. We want to find an equation for a line perpendicular to 2x plus y equals 5. That passes through the point 1, negative 3. So it has a point 1, negative 3, and it's perpendicular to this line. Well, the key thing that we can recall from the section on parallel and perpendicular lines is that parallel lines have the same slope, where perpendicular lines have negative reciprocal slopes. So first let's just calculate the slope of this line. We'll get it in slope-intercept form by subtracting 2x from both sides of the equation, which leaves us with y equals minus 2x plus 5. So this is now in slope-intercept form. We can see that the slope of this line is negative 2. M is negative 2. And whatever line we're finding, it needs to be perpendicular to this line, right? Well, it needs to have the negative reciprocal of this as its slope. Sorry, tongue-tied. But anyway, so the slope of this is negative 2, so we need to take the negative reciprocal. Well, negative 2 is the same as negative 2 over 1, so we need to take the reciprocal of that. So we flip it and then change the sign. So flipping it gives us 1 over 2, and then changing the sign turns the negative into a positive. So the slope of a line that's perpendicular to this line has a slope of a half. So now what we really need to find now is we're just going back to a problem from last time where we're given a slope and we're given, maybe I'll give this a different name, like m perpendicular or something like that. So we have this slope here, that's 1/2, and then we have a point 1, -3. So we can just use the point slope form of a line, which you can recall is given by this, y minus y1 equals m times quantity x minus x1. So therefore we can just plug in our slope of a half, which we need our line to be in order to be perpendicular to this one, and then we need to plug in our point 1, -3 as well. So in doing that, we get y minus -3 equals, y minus -3 equals 1/2 times x minus 1. And of course, this is the same thing as y plus 3 equals 1/2 times quantity x minus 1. So this is the equation of a line that is perpendicular to this line up here. So I think that's it for this video. We covered a good amount of ground. We covered how to find the equation of a line that's parallel to another line through a given point, and we also talked about how to find the equation of a line that's perpendicular to a given line and going through a given point. So in the next video, I think actually this will be the end of our videos on 2.5. There isn't a whole lot of ground left to cover. Anything else that's not covered in these videos I'll cover in class if I think it's important enough, but this section's a little bit shorter. So in the next video we'll actually trek on to chapter 3. We're going to skip section 2.6. We're going to go straight to chapter 3, section 1. So 3.1 will be the next video that we cover. I hope that this video was helpful. If you have any questions about it, please leave a comment or ask me in class or via email. I'm happy to help. And we'll see you guys in the next video, the next chapter, chapter 3, section 1.